1, 2, 3. Minasan, konnichiwa. Hi guys, my name is Muhammad Nurfitra Ramadhani.
Hello, I am Nurfitria Ramadhani.
Hello, my name is Masita Nurfadia.
Yes, how's it going?
What do you want in this video?
Friends, in this video, we will talk about first, the parallel postulate and special angle. The second, indirect proof.
So today we will gonna discuss about the parallel postulate and special angle. First of all, we're gonna talk about perpendicular lines. By definition, perpendicular line is two lines or segment or rays are perpendicular if they meet to form congruent adjacent angle. Using this definition, we prove the theorem stating that perpendicular lines meet to form right angles. Let's see this figure. This figure is an example of perpendicular lines, and this symbol or sign stand for is perpendicular to. For example, AB is perpendicular to. We can write AB is perpendicular to CD, as the example shows. Here's some example of perpendicular lines.
You can see in the first figure, lines CB and AB meet at right angle. Then, they are perpendicular lines. And the second figure, you can see that lines EF and FG do not meet at right angle. So, they are not perpendicular lines.
Okay, next I will explain about parallel lines. Do you know what is a parallel lines? Parallel lines are lines in the same plane that do not intersect. More generally, two lines in a plane, a line in a plane, or two planes are parallel if they do not intersect. Okay, see the figure 2.3. In figure A, two lines in a plane. We know that R parallel S, where R intersection S is empty set. Okay, in figure B, a line and a plane. We know that R parallel T, where R intersection T is empty set. Okay, for figure C, two plane. We know that T parallel V, where T intersection V is empty set too. Okay, next example. In the sketch, lines L and M lie in the same plane with line T and are perpendicular to line T. How are the lines L and M related to each other? Okay. In the figure, lines L and M are parallel, so they will not intersect. Next. Next is Euclidean geometry. In this geometry, a plane is a flat, two-dimensional surface in which the line segment joining any 2 points of the plane lies entirely within the plane. Now, I will explain about interior angle and exterior angles, corresponding angles, and alternate interior angles and alternate exterior angles. Okay, first, I will explain about interior angles and exterior angles. Before that, we know a transversal is a line that intersects two or more other lines at distinct points. All of the lines lie in the same plane. Okay, in figure 2.6, T is a transversal for lines R and S. Angles that are formed between R and S are interior angles. Those outside R and S are exterior angles. Relative to figure 2.6, we have interior angles is angle 3, angle 4, angle 5, and angle 6. And for exterior angles is angle 1, angle 2, angle 7, and angle 8. Next, about corresponding angles. Two angles that lie in the same relative position, such as above and left, are called corresponding angles for this line. Okay, in the figure 2.6, angle 1 and angle 5 are corresponding angles. Each angle is above the line and to left of the transversal that together form the angle. As shown in figure 2.6, we have corresponding angles is angle 1 and angle 5 above left, angle 3 and angle 7 below left, and angle 2 and angle 6 is above right, and angle 4 and angle 8 is below right. Okay, now about alternate interior angles and exterior angles. Two interior angles that have different vertices and lie on opposite sides of the transversal are alternate interior angles. And two exterior angles that have different vertices and lie on opposite sides of the transversal are alternate exterior angles. Both types of alternate angles must occur in pairs. In figure 2.6, we have alternate interior angles is angle 3 and angle 6 and angle 4 and angle 5. And for alternate exterior angle is angle 1 and angle 8 and angle 2 and angle 7.
Next, parallel lines and congruent angles. By definition, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So, let's jump to the example. We can see that line L and line M are parallel, and magnitude angles 1 is equal to 170 degrees. So we can find magnitude angles 5 because it's corresponding to magnitude angles 1. The magnitude angles 5 is equal to 170 degrees. And then we jump to the second theorem. The second theorem said that if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So, look at this picture. This picture said that line A and line B are parallel, and K is transversal. We will prove angle 3 is congruent to angles 6. So, first of all, we make a table. First, we know that A is parallel to B and transversal K. The reason is given. Second, angles 2 is congruent to angle 6. The reason, if two lines are cut by transversal, then corresponding angles are congruent. Third, angles 3 is congruent to angles 2. If two lines intersect, vertical angles form are congruent. And then last, 4, angles 3 is congruent to angles 6. The reason, it is transitive. So, by this example, this is an example of this theorem that we just discussed before.
Okay, next I will explain about the parallel line and supplementary angles. So, what is supplementary angles? According to the definition of supplementary angles, if the sum of measure of two angles is 180 degrees, then angles are supplementary. According to the theorem 2.1.4, if two parallel lines are cut by the transversal, then the interior angles on the same side of the transversal are supplementary. Next, according to the theorem 2.1.5, if two parallel lines are cut by the transversal, then the exterior angles on the same side of the transversal are supplementary. For example, look at the picture. Given line TF is a parallel to line WY with the transversal line RS. The magnitude angle RUP equals x plus 4 times x minus 3. The magnitude angle WXS equals x squared minus 3. We have to find the value of x. Solution: look at angle RUV and angle WXX are alternate exterior angle, so they are congruent. Then the magnitude angle RUV is equal to magnitude angle WXX. Therefore, x plus 4 times x minus 3 is equal to x squared minus 3. The product of x plus 4 and x minus 3 is x squared plus x minus 12 is equal to x squared minus 3. We can subtract x squared on the left and the right side. Becomes x minus 12 is equal to minus 3. We can add 12 on the left and the right side, and finally we find the value of x is equal to 9. If we substitution x equals 9 to equation, we can find both angles measure 78 degrees. Indirect proof. So what is indirect proof? Indirect proof is a logic proof that proves a statement true by proving that the contradictory statement is untrue. There are 4. The general form of first, conditional or implication. If P, then Q. Second, converse of conditional. If Q, then P. Third, inverse of conditional. If not P, then not Q. The last, contrapositive of conditional. If not Q, then not P. For example, for a conditional statement that follows, give the converse, the inverse, and the contrapositive. Then classify as true or false. If two angles are vertical angles, then they are congruent angles. Solution: first, converse. If P, then P. If two angles are congruent angles, then they are vertical angles. It's false. Second, inverse. If not P, then not Q. If two angles are not vertical angles, then they are not congruent angles. It's false. The last, third, contrapositive. If not Q, then not P. If two angles are not congruent angles, then they are not vertical angle. It is true.
Okay, next I will explain about the law of negative inference or contraposition. Okay, you can see equation. Consider the following circumstance and accept each premise as true. 1. If Matt cleans his room, then he will go to the movie. 2. Matt does not get to go to the movie. Okay, we suppose if Matt cleans his room is P, and then he will go to the movie is Q. Okay, next, Matt does not get to go to the movie. We can suppose is negation of P. Okay, so the question is, what can you conclude? Okay, You should have deduced that Matt did not clean his room. If he had, we could have gone to the movie. This backdoor reasoning is based on the fact that the truth of P then Q implies the truth of negation Q then negation P. So, you can see the law of negative inference contraposition P then Q and negation Q is negation P. So, if Matt does not get to the movie, the conclude is Matt did not clean his room. Okay? Next.
Here is an example of indirect proof using the law of negative inference or contraposition. Example: find a formal proof of the following theorem if two lines are cut by a transversal so that corresponding angles are not congruent. Then, the two lines are not parallel. Given the figure, line L and line M are cut by transversal T. Angles 1 is not congruent to angles 5. We have to prove that line L is not parallel to line M. First of all, we have to assume the variable. First, we assume P is line L is parallel to M when these lines are cut by transversal T. Q, the corresponding angles including angles 1 and angles 5 are congruent. But here's the thing, angles 1 is not congruent to angles 5 by hypothesis, which means this statement is negation of Q. So using law of negative inference or contraposition, we got if P then Q and negation of Q. So the conclusion is negation of P. Thus, the assumed statement which claims that line L is parallel to line M must be false. It follows that line L is not parallel to line M. So, it's proven. So that's all guys for our presentation. Hope you enjoyed this video.
Don't forget to ask
And like this video, subscribe and share.
And thank you.
Arigatou gozaimasu.
Dankeschön. Bye bye.
Bye.